1, Lesson 9, Lossless Compression. First, let's have a little warm-up. Get you thinking about it. Here's a list that represents several common abbreviations used in text messages. What are some other abbreviations you could add to this list? This list includes LOL, PY, see you soon. What are some more? In class, I would be asking for people to call them out or enter them into the chat. Here, think about it, pause the video, and add a couple more. Do you have a couple more? Great. Why might we use abbreviations when sending messages? What are the advantages? Jot down your answer to that question. And again, pause the video. This is going to be a lot of pause and go back. All right, so why might we use it? Well, there are many possible responses. We want to talk in code. We don't want people to know what we're saying. To hide information, to be clever, but more importantly, to highlight these particular abbreviations, we want it to save time and space when we are communicating. We want to communicate faster. We don't want to type out, laugh out loud. We also don't want to take up that much space. Remember, we're on a phone, and especially if you go back 10 years, you had a much tinier screen. So what about an abbreviation that not everyone knew? Was there, and if you're watching the video, you didn't come up with one that you didn't know, but if we're in class, somebody might come up with an abbreviation that you're not familiar with, or that I'm not familiar with. What happens then, and what's the problem? Well, both the sender and the receiver need to understand what the abbreviation stands for in order for it to make sense. Both of these points foreshadow today's activity on compression. I will date myself and tell you that the very first time I ever saw FOMO, I think my daughter-in-law texted it to me, talking about her dog was having FOMO about something or another, and I sent back, ha ha, what's FOMO? Because it's hard for me to figure out that it means fear of missing out without knowing it. So abbreviations are great, but both the sender and the receiver need to know what they mean. Now, we're going to look at our activity. And it's going to be this text compression, okay? Pitter patter, listen to the rain, pitter patter on the window pane. I want to send this message to a friend, but you know, their phone can only accept 80 characters of text at a time. I notice this pattern has some repetition in it. So rather than sending this whole message because my friend can't receive it, I sent this message. Star, listen to, sunshine, rain, star, on, sunshine, window pane. And I also sent the dictionary with the translation. When she sees a sunshine, it means underscore the underscore. An umbrella says TTER. You say, but there's no umbrella up here. But wait. A snowman is PI umbrella. I don't know what that is, like a shooting star, is PA umbrella. And a star, which I have a star here and a star here, is snowman, shooting star, snowman, shooting star. So not only do I have code for some of the letters, I have code for codes. But when you put it all back together, you wind up with the pitter patter, listen to the rain, pitter patter on the window pane. Now, how is this message the same as the first? How is this message here on my right the same as the initial? What actually gets sent to my friend? Jot down your ideas in your notebook. All right, and again, pause the video if you need a little more time to finish jotting stuff down. Using abbreviations and symbols is a form of compression, where we try to represent the exact same information with fewer characters. The original message This guy over here, he had 93 characters. But the new message and key, because I can't just send the message. The person receiving the message would have no idea what I was saying. So I have to send the message and the key. This has a total of 56 characters. We're essentially sending the same information, but with fewer characters. Our goal today will be to create our own text compressions using similar methods. Notice that 93, 56. This message is less than 56, but added to this message, I have to send the key as well. Otherwise, they don't know how to uncompress it. Now, text compression widget. This is where you want to go to Unit 1, Lesson 9, okay? And then go to Level 2. Level 2 in Unit 1, Lesson 9 in Code Studio or code.org. And what we want to do is try to compress the text. This widget will let you use symbols to compress the text in the center of the screen. You can type in the dictionary on the right-hand side. As you do, the text on the left side will update with your symbols. So you're going to find something. If I wanted to replace wake, and I don't know that it's repeated much through there, if I wanted to replace wake with an asterisk, I could put the asterisk and put wake. And any place where there was W-A-K-E, you would get an asterisk. Okay? So this is just to kind of get used to this widget and to test it out and see how you're doing. So go ahead and take about 4 minutes to try to compress this message as much as you can by typing in your dictionary over here. It will automatically fix up this guy. Go ahead and pause the video. Go to Unit 1, Lesson 9, Level 2, and try this. All done? Fantastic. So what strategies are you using to compress your sample text? Which ones seem most successful? Okay. So here I have didn't know I was lost. Replaced it with the star. Nothing else really seemed to be repetitive. But you may have picked something else. You may have picked didn't know and also replaced I was lost and made two different things, and then you could also get I didn't know here. Okay? Or didn't know here, didn't know here, and didn't know here. You have to play around with it and see how did your compression rating change. Okay? When I say which one seems most successful, it's what you want to look at is right here, your compression ratio. Okay? How well did you compress it? The compression ratio looks at your compressed text plus the dictionary. It gets a total size and compares that total size of the compressed with the dictionary to your original text. Now, at this point, what I want you to do is, if you're watching this video, you need to pause this video and watch the video that's on Canvas that I have that I've set up or linked to that talks about text compression. It is by this songwriter. Oh, now his name escapes me, but simply go to Canvas, click on it, and watch the video, and then come back. All right. Now, one of the things that I want you to remember is the widget we are using is an example of lossless compression. As you watch the video, you will have learned that lossless compression is when you compress data, but if you use the dictionary correctly, you can 100% recreate the message. 100%. There's no loss of information. The compression percentage at the bottom of the screen is calculated by comparing the number of bytes in the original message and the number of bytes in the compressed message. So again, lossless. This is big because we're also going to look at lossy. But today is just lossless compression. I'm going to redo that because I'm not striking through it. I am simply underlining it. Means that none of the information is lost. It is just compressed and it can be 100% recreated. Now, continuing on in Unit 1, Lesson 9, and the activity sections, okay, continue to try to compress the text using some of the strategies just discussed in the video, right? So wake me up when it's all over, when I'm wiser and I'm older. All this time I was finding myself and I didn't know I was lost, didn't know I was lost, I didn't know I was lost, etc. Okay, so now take another 4 minutes. And again, I stopped you quickly, didn't give you enough time to maybe do everything you wanted, and try to do this. When you're done, check your compression text ratio. Go ahead, pause the video, and give yourself another 4 minutes. Okay, notice that we are starting to reach the limit of how much we can compress this particular message. But not every message can be compressed with a high rating. We're going to investigate what makes some messages more compressible than others. In class, before we would do this, I would want to know, how did you do? Okay, so how did you do compressing the message, right? What were some of the compression ratios? Who got the highest? And if you got the highest, what did you do? Again, if you're watching this video, there's nobody to compare to, but you can think about the things that you did. Now, continuing on with the lesson, I want you to click the drop-down menu, okay? And I'm showing you up here. So it's got up here, it's got this drop, it has to wake me up when it's all over. Click on that, and it'll drop down all of these items to explore other texts to compress. Be looking for texts you predict will be easy to compress and texts you predict will be difficult. So if you're not sure what these are, I mean, here's the pitter patter one, the man, I need $1, a tutor who tooted the flute, tried to, she sells seashells on the seashore, I know an old lady who swallowed a peas porridge hot, peas porridge cold, etc. And then, whichever ones, take a quick look through these. Again, you can pause the video, take a look through them, figure out which ones you think will be easy and which ones will be difficult. Easy and difficult compressions. Your first step is to choose what you think will be an easy message to compress and which one you think will be hard. Note in your notebook which one is which. Now, if we're in person, I would ask you to do this together. So I would ask two people sitting close to each other to decide on an easy and a hard. Then using one person's computer, I would want them to work together to compress the easy message as much as they felt like they could. And then using the other computer, work together to compress the difficult message as much as they could. Since we are not in person, if you're watching the video, you're obviously not in person, you're going to do this on your own on one computer. If you're alone, what I want you to do is after you have compressed the easy one, note the compression ratio. Okay, compression ratio is right down here. Compression and the percent. So I want you to note that for the easy one, and then obviously do the hard one, and you'll be able to look at it. Give yourself about 15 minutes to perform this exercise. Remember, we don't want to, the idea is not to spend hours and hours and hours. It's to get a good idea of what it takes to do this compression. So take about 15 minutes, pick an easy one, pick a hard one, and compress. If you're watching the video and doing this without the class, just pause the video now, give yourself a timer for 15 minutes. You're back. Fantastic. First off, before we go, I would want to know, how did you do? Was your easier one truly easier? Was your harder one truly harder? Okay. What were your compression ratios? In your notebook, I want you to note what made some messages easier to compress than others. What made some messages more difficult to compress than others? What do you term as easy and difficult when you're talking compression? You can pause the video and answer these. All right, again, since you're watching this video, I can't ask you what your answers are. If we run class, I would ask for some responses, whether in person or virtually. Finally, what I would like to make some remarks on it, just so that you would have some ideas if you hadn't thought of much. There are many strategies that can be used when creating lossless compression, and there isn't a single best way to do it. It really depends on the message that you're trying to compress. Instead, our compression rate usually depends on which strategy we choose and the patterns in the text we're compressing. So it's a combination, okay? Didn't know what I lost. If those words don't appear anywhere in a text, it's not going to help. Okay, most importantly, even though the number of bytes is getting smaller, we're never actually losing information. We can always perfectly recreate the original message using our dictionary key. This brings us to today's vocabulary term, lossless compression. Lossless compression, a process for reducing the number of bits needed to represent something without losing any information. This process is reversible. Not just reversible, but 100% reversible. You squash down your message and you can open it back up and boom, it's exactly what you sent. There's no losing. This isn't like the game of telephone when you were a child and you sat in a big circle and somebody whispered a message to the person on the left and they whispered the same message and it went all the way around. By the time it got back to the first person, it was a little crazy. Okay, maybe it wasn't even the same thing. Lossless compression. When you pass on this message along with the key, the whole thing goes through. Now, next time in AP Computer Science Principles, we're going to look at lossy compression. What do you think lossy means?